IMSAI Dog's been very excited ever since a very big box came to the house. He's been wondering what's inside. He's going to give it the smell test, make sure it's okay. All right, what's on the bench today is the new Keysight HD3. This is their new 1 gigahertz oscilloscope. Let's take a look at it. It's a beauty. A big thank you to Keysight for trusting our channel and giving good reviews and stuff. This is sent in for the channel, so you'll see it prominently placed on my bench in the future. I'll have to find a place for it. So one of the really nice things about this, other than it's 1 gigahertz, it's also a very big bit depth. So it's 14 bits, and it will go to 16 bits, and we'll show you that. It is a 4-channel scope. It has a very large display, which I'm excited about for the channel. Is it'll photograph easily. Yes, I can do screen captures and things like that, but when you're cranking out videos on a fast basis, you really don't want to have a whole bunch of B-roll that you have to edit in and stuff. So it's nice to have a nice big screen. This is like a 10.1-inch screen, so that will be very nice. It's got the fancy inputs, so you can put active probes on it, and also has internal 50 ohms, which are completely required to get up to a gigahertz. On the back, we've got LAN connection, USB connection, display port, a connection for more. I think you can control it over, I think this is probably for something like a mouse, and this is probably something for controlling it. We've got generator out, so it has a built-in arbitrary generator. It has an aux out and an aux trigger, and then it has a digital connection here for the logic probe. So it is an MSO oscilloscope. So it has both analog and digital built in, 16-channel digital and 4-channel analog. So let's turn it on. All right, so when you plug it in, you get a soft start button here. Everybody is going to hate this part of the oscilloscope. So we will push the button and start the timer. All right, that was 1 minute and 11 seconds. So yeah, we'll get the bad news out of the way. 1 minute and 11 seconds. So a lot of modern equipment needs to boot, and they do take a long time. It's not like the old days when your analog scope would just turn on. Yeah, here we go. All right, the scope came supplied with 6 passive probes. 4 500 megahertz probes and 2 1 gigahertz probes. So I'm going to put one of the 500 megahertz probes in. It has the auto detection that it's a ×10 probe, and it has probe compensation on the front here. So we'll hook that up to get a signal. And let's just do auto scale just for fun. It has a very quick auto scale. I do like that. So yeah, let me arrange things here to get a little bit of the glare off. All right, so the layout, it is a touch screen device, and a lot of the menus are touch. So I think that's just the future. I don't particularly like it, but there's so much functionality built in this thing, you're just gonna have to live with it. I believe it probably operates with the mouse, but I'm not gonna use a mouse on the bench. So it's going to be touchscreen, and that's gonna leave a bunch of marks on the screen as well. But yeah, so it has a lot of menus, and the thing at the top here, like the settings for channels 1, 2, 3, 4 and stuff, they're all going to be touchscreen type of items. Now, let's go through what it has for buttons. It has channel 1, 2, 3, 4, vertical and vertical gain, and then vertical position. okay, for each channel. It then has a measurement channel where you can set cursors and stuff. It has automatic frequency and peak slopes, rise times, all that kind of stuff in measurement. Digital gets you to the logic probe in the back. We'll do that later. Protocol decode. It does have markers, and so you can turn on various markers, and then it has up down for the markers, and left right for the markers. So that's that button. The wave generator in the back. I'll show that later. Save screen. You can save snapshots to the hard disk inside or to the USB on the front. Touchscreen you can enable or disable. Triggering is here, so you have different things for your triggering, trigger mode. You can also just do it from here. This is your trigger menu, so you have edge, rising, source. You can figure out which source that you have, conditioning like hold off and things like that. So I just use this for the triggering. It also has a button here for slope, so you can have both rising and falling, just falling or just rising. Clear display in case you get things confused. Default setup, and then auto scale, and then it has zoom, so you can zoom in on an edge, and move it back and forth. Run stop, single shot, all that kind of stuff. Let's see. Let's take a look at what type of options this thing came with. All right, so if we go here to utility service, here is what I have loaded in. So let's zoom in on that. All right, so we have, the first one is not enabled, some security option. Then I have everything else. So we have the WaveGen enabled, automotive analysis, embedded protocols, acquisition is 100 megapoints. It looks like it has lower ones if you don't pay enough money. 1 gigahertz bandwidth and lower. And then at the bottom here, there is no distributor license, but I do have the demo license. So there are some menus in here that are for demos. I don't find them quite very useful. They're mostly for a field sales guy to show you some capability, but we're going to do that ourselves. So that's what's loaded in this thing. All right, let's get a complicated waveform on the screen, and I'll show you some things. All right, I'm going to be using this board. I have this Tektronix board that's a demo board for high-end oscilloscopes, and this will be great for this oscilloscope. It's got QAM, and it's got runt pulses, and it's got fast edge. It's got a bunch of stuff that's very, very handy for testing oscilloscopes. So we're going to use this. And you can either power this thing up with the power supply, but you can power it up with USB. And we have a USB connector on the front. So here, we're going to plug this into the front, and now our board over here is functional. All right, so we can move. Let's see, this is channel 1. So let's do a ground, and we will connect channel 1 to the clock here. And now we have some clock pulses. Let's zoom out. There we go. Wacka wacka wacka. Let's get a second channel going. All right, I'll put the second channel on a QAM signal. We'll turn on channel 2, and we will take a look at what we got here. Let's clear the screen here. All right, so here's our channel 2. So you can set this thing up so that you can have things go top and bottom. Or you can, you can set up the display. Let's see here, set up the display to do side by side this way, or you can set them up to basically old school, which is they're all on the same thing. So if I hit channel 1, it'll come to the front. So there we go. We've got the QAM signal here, and we've got the clock. So this is the data. This is a data valid pulse, right? And you can see that we're running at high speed, right? The oscilloscope's running at 1 gigahertz. The scope probes are good to 500 megahertz. Let me show you the coolest thing, I think, is this button here. So we have, shows us a bandwidth of 500 megahertz because we're using these probes. We have 14-bit resolution. Sample rate is 3.2 gigasamples. Analog depth is 32K. And then, this is the cool thing here, global bandwidth. You can set the global bandwidth to 350, 200. When you get down to 100 megahertz, it drops to 15-bit, or goes up to 15 bits, high definition. If you go to 50 megahertz, you're now running 16 bits high def. So let's do that. Look at this. Look at how beautiful that display is. Woo, it's a beauty. So isn't that pretty? That's the 50. If we go to 20, I think it even gets a little cleaner. We'll go to 20. Yeah, it's even a little cleaner. Look at that. That's a joy. Yes, sir. So these are, if you're not familiar with QAM signals, these are various ones. If I do single shot, it's actually, the data is coming out like this, but when you're sending them at all at the same time. So these are signals, and it's data valid here, then it has to go to the next value, which is here, the next value, which is here. And if you run them all together, you get this pretty thing here. Now, what I would have liked to have done is to put on a third channel and do an XY and get an actual satellite constellation diagram for the QAM signal. But XY mode is not in the software yet. I've been told it will come out 4 to 6 weeks after release. So as soon as it does come out, I should be able to get a firmware update and go from there. It's going to be a free upgrade for everybody. They're going to add 2 features that aren't in the software right now, which is XY mode and scroll. The rolling horizontal is not implemented right now as well. So it is a new product. All right, so let's zoom in here. Let's see here. Yeah, look at that. Oh man, is that pretty? Yeah, I like this. And then you can see that it's really screams when you open it up all the way to 500 megahertz. You can see all the noise and everything and all kinds of things. All right. So I think one of the first things we're going to do. Let's see. Now I'm going to wait one. We're going to show you one more feature, and then I'm going to then we'll go measure the bandwidth of this thing. All right, so on my demo board, I also have some digital signals. I have them hooked up to the logic probe, which is this thing here, and it has a connector. I don't really like that you have to plug this into the back of the instrument, and I don't like that they didn't use the space here to bring out the our generator. I would have liked to have the generator here. I can sort of live with this in the back, but again, it's kind of nice to have everything on the front panel. But let me plug this in. All right, so we hit the digital, and it says, what do you want to take a look at? And we don't need any of these, so I'm going to erase those. It's just 4 bits plus D15 is going to be our clock. And we will get rid of this. And let's turn off 1 and 2. And there we go. That's what we have. Let's change the triggering to D15, which is the clock. And we will set the display to be large. And we have D0 through D3. And if I hit single shot, there we go. You can see that we have a whole bunch of random things here. So it's just running really fast now, but every time we hit single, we will get data out, okay? Another way that I could do this is it's running so fast, I can do a conditioning. We'll do a hold off. We'll do 100 millisecond hold off. And now it's only triggering every 100 milliseconds, so we can actually see the digital data kind of in a fun fashion, okay? We can also turn on the bus. We're going to look at the bus here in hex. And so down at the bottom, if I hit, you can actually read the hex values of these counts down here. So that's super cool. Okay, so it does have all the cool digital stuff built into it, and you can do. We could go back to setup. We could do our display, stack them vertically, and then turn on channel 1. So now we can see here is our clock, here is our digital data, and then here is our analog data from the QAM, and that these random bits here end up being random analog voltages here, and that's the way it's working. All right, so let's go ahead and hit the default setup. Let's get rid of these oscilloscope probes. We're going to test this thing for 1 gigahertz. Okay, so currently we can hit this button that says that we have 500 megahertz bandwidth, and we are going to take the output of this device here, which has a rise time of 57 picoseconds. That was measured by me on a 70 gigahertz oscilloscope. Okay, so I measured it very, very accurately at 97 picoseconds. So we will take that and we will run that into channel 1, okay? And there we go, we get a clock. And we need to turn on 50 ohm loading, so we'll go to here. We'll change this to 50 ohms. Did you see that? I pushed the 50 ohms button here, okay? And so now we are good to go. I'm going to come up here again to the bandwidth, and it's saying I've got 1 gigahertz of bandwidth. I've got 14 bits, and I've got a signal. So let's open that signal up. Let's zoom in on it, and there it is, okay? So I can go one bigger. All right. So this is our 97 picosecond rise time here. We'll go max on the horizontal display. So it's 500 picoseconds per division. That's pretty screaming. And then we can turn on measurements, which is a time measurement. We want to take a look at rise time, and we'll add that. And it will put on the markers, and it's showing us we have about 411, we'll call it 414. It's an easy number to remember. 414 picoseconds of rise time. Okay, so now we need to do a calculation, so let's get out some paper. All right, so back in the old days, you will see the formula 0.35 divided by rise equals bandwidth, okay? That 0.35 was derived with analog circuitry and Gaussian filters and stuff. With modern digital oscilloscopes, that 0.35 is no longer valid. It's a lot like, I did a video once about the resolution bandwidth of digital spectrum analyzer, how they're much, much different than analog spectrum analyzers because of the shape of the filtering. And using fancy digital filtering, this 0.35 is no longer valued. But according to Rodenschwartz and Keysight and Textronics, it's now 0.45. That's the value to use. 0.45 over the rise time is equal to the bandwidth. And what is our rise time? 414 picoseconds. Okay, so we need a calculator. All right, so we have 0.45 and we have 414, enter exponent minus 12 picos. We have that, and we do the divide. We have 1087 megahertz, okay, so 1.08 gigahertz. So yes, indeed, it is a gigahertz scope, okay? So if you don't trust rise time measurements, and I can see why you might not, let's do it a different way, okay? We will put in a real sine wave at 1 gigahertz and see how the scope does, all right? All right, so I have my VNA over here. We're going to use that as a RF source, okay? And the way that you use a VNA as an RF source is to boot it up. Wait. This boots faster. No worries. Okay, so you go to frequency, and we can go to CW mode. Don't do start, stop, and everything. You go to CW mode, and then you can tell it what frequency. And here it says 800 megahertz. So we have it set to 800 megahertz, all right? And we will have to go back and take a look. All right, so here we have a sine wave that has some jitter in it, okay? So I'm going to set averaging. And how do I set averaging? Is it with this one? Yes, averaging, and there we get a cleaner looking display. All right, so this is our 800 megahertz display, okay? And so we can do a measure. Let's see here, we can measure the frequency, and we can measure the amplitude. Let's measure RMS voltage, which is up at the top here. Yeah, here. Okay. All right. So the numbers to take a look at is at 800 megahertz, we're getting about 100 millivolts of RMS voltage. Okay. Let's change our frequency to 1 gigahertz, and now we've gone to 1 gigahertz, and our counter says 1 gigahertz, and again we're still at 100 millivolts, okay? So it's doing 1 gigahertz, exactly the same amplitude as 800 megahertz or anything lower than that. It's completely flat with frequency up to 1 gigahertz, and I did do a measurement going a little bit farther, and I think it's about 103. All right, so at 103 gigahertz, it's dropped to, we're not quite there. When we go down to about 70 millivolts is where the cutoff would be. So 1035 megahertz. Yeah, right about there. So about 1.035 gigahertz is its roll off, okay? So it's a really good 1 gigahertz oscilloscope. All right, well, there you go. Thanks again to Keysight for the generous donation. And we will be running this thing through the ringer in later videos. It will become the main oscilloscope here on the channel. And like I said, I need to find a space for it on the bench because it is larger. But I think I have something figured out, so we'll go from there. Anyway, that's the first video in many. This is the HD304MSO. Very nice.